David works as a staff engineer in the plan review team of the Plan and Technical Review section. David received his Bachelor of Science in Agriculture and Engineering from Texas A&M University. David is a licensed professional engineer with 35 years of experience in state agency service in water and wastewater related programs. David worked for the Texas Water Development Board for 30 years in the financial related construction programs, has been at TCEQ for 7 years. So here's David. Just remember, have all phones on silent and enjoy the presentation.
Well, we're going to talk a few minutes about well construction, and in particular, we'll be looking at things that the TCEQ looks for in well construction, but hope to give you a framework of the kinds of things that we're looking for to protect public health. We have a multi-barrier strategy to try to protect public health. We look at where are you going to put the water well, the site restrictions, the way the well is constructed, and then of course the next thing is you treat the water with disinfection to protect public health, and then there's the ongoing monitoring. So all these things work together to protect public health. We're going to be concentrating on the site and the well construction, but just kind of giving you that framework. The TCEQ rules that apply, 290.41C covers groundwater resources. And one thing I'd point out is these books are over there in that area where the technical advisory groups are sitting, and you can go in there and grab one of those. If you don't have a copy of the rules, of course, you can look them up on the internet. And then 290.42B covers groundwater treatment, the various kinds of groundwater treatment, particularly iron and manganese removal, those kinds of things. Now, there are other rules that might affect water wells. One thing is, if you're going to drill a water well for your public water system, you're going to get a licensed water well driller to come drill that well for you. And he's going to be licensed by the Texas Department of Licensing and Regulation. And so whether he's drilling a domestic well or a PWS well, he's a licensed well driller. And so there's certain rules that he follows if he's doing a domestic well, and then there's additional rules when it comes to doing a PWS well. And both a domestic well and a PWS well would be subject to local groundwater conservation districts. And I guess folks are familiar with it. In Texas, there's about 100 groundwater conservation districts now. Maybe it's more than that now, but they regulate the withdrawal of groundwater in different counties around the state. And so, you need to be familiar with, are you in one of those? And you can go to the Texas Water Development Board's webpage, and they have they have maps that show where the groundwater conservation districts are. And also the Water Development Board has rules that guide some of the actions of the groundwater conservation districts. But those rules could apply to your well. So one thing, we just wanted to kind of throw up a slide that kind of contrasts what a PWS well and a domestic well, the difference that there might be between them. And sometimes people are calling me and they want to put a business on a piece of property, and they realize they're going to be a public water system, and they're complaining because, well, I already have a well. Well, your well is probably not according to the designs of a public water supply well. And so this kind of shows that picture. One thing, your public water supply well, we're trying to say you need to have let's say you've got a 10 3/4 inch outside diameter casing that you're sinking into the ground, then you would need 13.75 inches of, the hole would need to be 13.75 inches or greater in diameter. And we're looking for a 3-inch greater diameter on that that hole, or 1.5-inch greater radius. And what that gives us is this area around the casing to pressure cement. And the idea of the pressure cementing is you're taking a neat cement. There's no sand or gravel in this cement, and you're putting it under pressure. It's pressurized cementation, and that you're trying to push that cement into the fractures in the hole and create a good seal between the hole and the casing so that there's no pathway for contaminants to come down to the water that we were trying to develop. So that cementing goes all the way down to the layer that you're trying to develop for production. And so you're trying to cut off any pathway for contamination. And you can see that in the public water supply well on the left. And then also you see the cap that we put at the top on the surface, make the water drain away from the well. Then you compare that to the domestic well, there's not, I think it should be cemented at the very top, like the top 10 feet, and then it will have a skirt around the well, but it could be completely uncemented all the way down the hole, and they do kind of recommend something at the bottom of the hole. But you can see the difference. We're trying to eliminate any pathway of contamination down to the aquifer that we're trying to develop. Now let's talk a little bit about, if you're developing a well, what do you have to do with regard to the TCEQ? Well, you're gonna develop a proposal for your well, which will be the plans and specifications created by an engineer, and he's going to have other pieces of this that he'll bring to the TCEQ, and then the TCEQ can, if we approve it, then you can move on with construction of that well. So there's a two-step process. We approve the construction, then you go ahead and proceed with construction. And then the step two, once you've constructed the well, now you have water samples that you can bring us, you can send us a copy of the sampling so that we can look at this is what the water quality is. Can we approve that water for consumption by the public, or is there going to have to be additional treatment? So there's a second step, and if we approve that, then you proceed to use the water. There is a final step whereby there's a TCU contractor that will come out and take a sample of your well while it's in production, and we'll do a whole lot of water quality testing on that sample. And if it confirms that everything's good, well, then you're in good shape. If that test were to show some problem, then we would have to get to work on what to do about it. So that first step, step one, what do you bring to the TCEQ? Of course, the engineer will create a cover letter. There's a form that we ask to always be with our submittals that it gives us a lot of basic information that some people will forget if it's not there. The engineer will provide an engineering report, a pollution hazard survey. We'll need, if needed, we'll need the draft sanitary control easements. There'll be we'd need a location map and the plans and specifications for the actual construction of the well. So now, if somebody's presenting something for a new public water system, we get a lot of new public water systems for businesses and RV parks and all kinds of things like that. So we have to have a business plan, show us that you have the financial wherewithal to maintain a public water system. There's a core data form that really discusses the form of business. And then also you have to show us that you've looked into whether you can get water from nearby systems. So that's what we ask for new systems. Now, the engineering report would be, we'd look for a map that shows the area to be served and a discussion of, what kind of facility are we creating? How many connections do you have? what's the population you're expecting to serve. So then that goes into what capacity is required for the facility. And then also, especially if it's a new facility, you'd need to talk about the rest of the system being what are your storage tanks, your pressure tanks, your service pumps, and disinfection. So all of this could be covered in the engineering report. The siting of a well, it's critical to look at what is around it. So we start looking at a pollution hazard surveys. Are there abandoned or inoperative wells nearby that, a nearby well that it's not been capped or something? It could be a pathway for pollution down to the aquifer. Are there landfills and dump sites? And so you see the list of things there, and these are in the rules. But we look at the area around to see if these things are located within the area that you're developing for water supply. Now, we look very closely at what's within 150 feet of the well. Within 50 feet, you can't have livestock in pasture very near the well. You can't locate a septic tank or sanitary sewer, and you can't have a storm sewer that close to the well. Within 150 feet, we don't want a septic tank drain field. Like if you're building a gas station, you can't have the gas tanks and all of that equipment within 150 feet of the well. And we don't want to see any improperly constructed wells, especially within 150 feet of the proposed well. Some other things, 300 feet, we don't want to see a wet well within 300 feet or a lift station. A drainage ditch that's carrying effluent from a treatment plant or an industrial waste facility, we don't want to see that. And 500 feet, we don't want to see a sewage treatment plant or animal feedlot. So this next slide kind of, these setback distances are what we're discussing here. So you can see we don't want to see these, we'd like to look at everything within at 500 feet and even out to a quarter mile from your well, what's there. And then the 150 feet, we're going to require a sanitary control easement against that area. So, the proposal for the wells should have a good map that cites exactly where the well is. It's very good to have Latin long on that site. And then we were talking about a sanitary control easement. So if you own all the property within 150 feet of the well you're proposing, then you have sanitary control. If our inspectors come out and find that, you're storing barrels of oil right there on top of the well, we'll get those out of there. But if you don't own the control all of the land around it, then you have to get a sanitary control easement from your neighbor. That's the procedure. And so that sanitary control easement says none of these things can be constructed within 150 feet of the well. And then that's recorded at the courthouse, and so that becomes a permanent feature of the property that, if that property sells someone else, it's still prohibited for anything to be constructed near the water supply well. So we don't require the sanitary control easement when you're constructing the well. We'll require that be executed before we look at this step 2 and then grant you use of the well. So when it comes to the actual construction of the well, we want you to be careful about some of the methodologies you're using in constructing that well. Be careful that you're just in the construction process, you're trying to minimize contamination. What you're doing is drilling down to that aquifer. We require, like the mud, to have a 0.5 milligram per liter chlorine residual. be careful where you build your slush pits and that they're not draining into the well. We don't want to see any temporary toilet facilities within 150 feet of where you're drilling this well. So, there's just being careful about the construction and not contaminating the water while you're doing construction. Another thing is the materials that you use, the well casing itself. And I guess I should say that any well, public water supply well, has to be constructed according to the American Water Works Association A100 standards. And that has standards for the casing of the well, what kind of materials you can use. And so it needs to be spec'd according to those rules. And of course, it can't contain more than 0.25% lead. And then the specifications also need to detail that cementing of the well, that it's going to be pressure cemented, and all of those details, we'll be looking for all those details as we review the plans and specs. Then when you think about the well head, that part that you'll see on the surface of the ground, we require that it be 2 feet above the 100-year floodplain elevation. So we're trying to protect it from flooding. The edge of that slab stretches out 3 feet away from the well casing in all directions, and then it also slopes away from the well, so we get drainage away from the well. The concrete around the well casing is sealed with a gasket or sealing compound. You would want to see the sampling cock where we can get a raw water sample. There's flow measuring devices. All of these things are incorporated into that wellhead. And some other protections. If you're using a gravel pack, well, then that gravel pack is disinfected. You need an all-weather access road so that you can take care of this thing, an intruder-resistant fence, and one of the final steps is after you've developed the well, you disinfect it for 6 hours, and there's an AWWA standard for how you disinfect a well. So, and then, as we talk about any raw water from a well before it goes into the public water system is going to need to be disinfected, and we'll be looking for those facilities for gas chlorine or sodium hypochlorite. And of course, if it's chloramines, then we'll be looking for the addition of ammonia. And then wells could require treatment, and typically, out in West Texas, we might see high arsenic or nitrates, and so you'd have to have your treatment approved to remove that if it's elevated above the MCL. Often you've got iron and manganese problems, and that's one of those things that sometimes you can sequester the iron and manganese and be okay. Other times you have to, if it's above like 1 milligram per liter of it, then you're going to have to be dosing it with, you're going to have to treat to remove the iron and manganese. There's rules we have for, a lot of communities have high total dissolved solids in the water, and so there's rules for treating with reverse osmosis. And at times there's wells that have a problem with bacteriological contamination, and if you've got that, then you may even have to go to 4-log removal for inactivation of viruses. So, if you have bacteriological contamination, you know, we have a word for that. We call it groundwater under the direct influence of surface water. You'll hear us use the term GUI, G-U-I. And this is supposed to be a diagram that just kind of illustrates if you put your well near a water body, you may create a situation where you're actually drawing water out of the stream, and so you're actually getting something more like surface water in your well, and that'll show up as bacteriological hits on your raw water samples, and that could get you in a place where you're a GUI, and then you've got to treat and what we call 4-log removal of an inactivation of viruses. So now, all of what I've described are the rules. This is the way we want you to build the water well. And of course, there are times when we can't get that guy to give us a sanitary control easement, or we do have this in the water and we've got to treat for this, and so sometimes there's an exception required. And we want those exceptions to come before you submit for plan review, because if you need an exception and you bring it to us first, we're going to say, we're going to disapprove it and send you to the technical review and oversight team for an exception. So the best thing to do is be aware of the rules, figure out where am I going to have a problem, figure out whether you can solve that problem. If you can't, then proceed over to get an exception first. That would be the best thing as far as time. And so you submit the project, that detail. We need an exception for sanitary control easement because the neighboring property will not allow us, will not give us that sanitary control easement. Trot will look at it if they think it's that they can figure a way. The thing about an exception is it has to be. It's not like, here's the rule, and so we're going to accept that the water is not going to be as protected. No, they're going to come up with some rule to help make this equal to the rules and protect the public health. If Trot approves your exception, you submit it to Trot. If they approve it, then you can proceed and bring the plans to us, and then the plan review team will review the whole thing and approve it. And then you can go ahead and construct your water well. Some common exceptions that we do see, say like for instance, the neighbor has a well that's uncapped and it's not a well that's drilled to public water system standards, and it's sitting there 125 feet from the well. And so we request an exception to the rule about setbacks, and then they would probably require some water quality testing, some bacteriological testing to be done. Like we said, sanitary control easements is a common exception. Sometimes things happen during construction that require an exception. The cementing didn't go well. Here around Austin, where the Edwards Aquifer is, sometimes the ground has caves, and when you go to cementing the well, you're trying to fill a cave, and so it's in those cases there might have to be an exception for the cementing the well. So some of the things that the exceptions group might require, like say for instance, if there was a petroleum tank that you're developing a gas station and some of the stuff is going to be close to your well, then we might require a steel casing rather than a PVC casing. We might require increased water sampling. And one thing about exceptions, they are subject to, they could be revoked if we see a problem, or if we start realizing that we've been granting this exception and we've been seeing this problem, they could be changed or something. So you get your TCQ approval letter for your well, and you construct your water well, and you construct it according to the plans and specs. 48 hours before cementing the well, you should notify the TCEQ that we're about to cement this well. And so occasionally, our folks may come out and want to watch the cementing of the well. And of course, you can always contact us if you run into a situation where, well, we were going to put it here, but now we realize we're going to have to move over or whatever, and you can call us and talk to us if you got problems like that. Okay, so you've constructed your water well, everything's gone great, and now you've got water quality samples, and you're ready to send in step 2. So this is kind of a description of the package that the engineer would send in. The State of Texas well report. The well driller is required to turn in these well reports, and they have a good bit of information on the well, and it's good for that to come into us. If there was a sanitary control easement that needed to be executed, well, we need to have that executed and show that it was recorded at the courthouse. The well location, give us the lat and long of the well location. A 36-hour pump test. We want to see that well is able to pump and what it's able to do over a period of time. And then you have your chemical analysis, bacteriological tests. We want 3 consecutive days of bacteria test to show that, we really have a clean well. And then we'll also look at corrosivity as we look at a well for approval. So, and I imagine many of you have seen us doing this in the last few years. We want to see that water quality that we can look at with indices to see whether the water is corrosive or not. And then if it is corrosive, then if it's corrosive, we might require you to go ahead and treat before we would approve it. The final steps are you receive plan approval, and then you need to contact the TCQ and arrange for the official samples. So this is in your approval letter. You're supposed to contact us about, and so we send out a contractor. It takes a water sample, and this becomes kind of more the official water sample. An independent lab takes a look, and then if everything's good, then you're good to go. And of course, there's continuous monitoring of your water source. And wanted to put up the names of our plan review team, and we're available, and there's our email addresses. And we're quite glad to talk about any questions you have regarding the project that you're trying to do as you're in it. And also, I would encourage you to get familiar with our web page. The plan review team, you can go to our web page and then type in plan review team, and you'll come to some of these checklists that we use, and you can, I think you'll just find that useful in familiarizing yourself with what you need to submit to us. So, do we have any questions? Typically if it's more than 100 gallons a minute, and you can ask, and we can consider, and especially at this time, I would say send us an email, ask about it, because in those kind of, in this drought, we understand. And what we look for is that the drawdown begins to, the curve begins to just go flat, and if in 4 hours it's not pulling down much at all, then we can probably go with that. If we're going to have a long question, come on up to the mic. But he was asking about whether it had to be a 36-hour pump test, and so I was saying that we could work with them during this drought. And I guess the reason I'm repeating that is there are people listening by Zoom. So, yes, sir. I'm really not an expert on what groundwater. I think they would have control, I mean, have jurisdiction, but I would think that they would, most of them would listen very closely to a public system's needs. I don't know whether there'd be people at the Water Development Board that could guide you. I mean, of course, the Water Development Board is both concerned with having enough water for everybody and guiding those districts to, they have the desired future condition of those groundwater conservation districts. And so they have both sides of that coin that they're looking out for. So they may have some rules that or some guidance for you. So I would talk to the groundwater people at Water Development Board. Yes, sir. So the question was, an RV park wants to use an existing domestic well. And so there is a guidance we have for as-built systems. And so you could pull that up, and it's on our webpage, and you can look at it. And then, yeah, there will be exceptions required. And so often domestic wells can be purposed for public water, but with exceptions. And one of the things I tell people when they go to wanting exceptions is, well, the exceptions groups gets to write the rule for you. And you may not like the way they write the rule, but, because you're not fitting the rule, so they're going to make the rule for you. But often, that happens a lot, that people do take a domestic well and get it approved with additional monitoring. So, yes, sir. I guess the public water systems need to be at the table as they're writing those rules for that particular groundwater conservation district as to what the restrictions will be. Yes. Pilot studies. So let's see, if you have a contaminant in your water that, the way our rules are written, there are different things in the rules, and if you're doing treatment that's in the rules, then, we just apply those rules to your treatment. But if you're doing something that there's nothing in our rules regarding to how that contaminant is removed, well, then you're going to need to do a pilot study to document that that will remove what you're doing. And so, yeah, there are times when somebody would need to do a pilot, and of course that you really couldn't do a pilot until you've drilled the well and are drawing water, unless perhaps if you were drilling a well 100 feet from an existing well, but that's going to the same aquifer. But yes, sir, in the back. I think I agree with you that we see a lot of things where, there's coordination going on between the groundwater conservation district. Like, Buda was taking a well that we were going to take some water out of the Edwards and put it down in a deeper aquifer as aquifer storage and recovery. Of course, I shouldn't bring that up. That's a whole nother topic, but anyway. So I think, any other questions? Well, thank you. You've been attentive. All right.